So what we're looking at today is how to prove series. Now if we look below, we've got the series. The sum of 5i equals 5n times n plus 1 all over 2. What we want to do is, using proof by mathematical induction, prove that the left-hand side is equal to the right-hand side, where our conditions are n are that it's an integer and it's more than 1 or equal to 1. So because it's proof by induction, well, firstly, do we know what this symbol means? Do we remember it from methods A, Brad? Yeah, sum of.
Is it sigma?
Yeah, it's sigma ris.
That's a technical term.
Yep. My year 7s were mesmerized yesterday when I showed them that sigma was an actual math symbol. But anyway, so what this means is that for every value of I, starting from 1 all the way up to m, we're going to sum 5i together. So it's 5 times 1 plus 5 times 2 plus 5 times 3 all the way up to 5 times n. Add them all together. So because of that, we're going to jump into our base case. And our base case is always going to be, in this instance, P of what, please, Nick?
P of 1.
P of 1. Because that's the first, as defined
What
over
does it
here.
say under sigma?
Sorry?
What does it say under sigma?
I equals 1. Okay, now because of that, we're now working with an equation as opposed to an expression from last time. We're going to go LHS for left-hand side. When P of 1, so n equals 1, we're going to get...
The camera's black. I'm not sure if it's on.
Oh no, I got the screen turned around.
Oh.
Yeah, so I can make sure it's actually recording what I want it to record.
Oh, cool.
Last time it didn't record what I wanted it to record.
Yeah, smart.
Okay, so we replace n with 1, and then it's 5i. After that, we can start unwinding the summation, in which case it's, first one is just 5 times 1, and that's just 5. So the left-hand side is equal to 5 in the base case. For the right-hand side, what we're going to find is that it's going to be 5 times 1, 1 plus 1 all over 2. That's going to turn into, the 2 and the 2 cancel, so it's just 5. Are we cool with that so far? It's a happy place. It's our base case. Now, since we've done the base case, we move on to something a little bit trickier. We go on to the inductive case. For the inductive case, what do we always assume, Mad Dog?
PK is true.
Yeah, assuming that P of K is true. If P of K is true, then the only thing changing on the left-hand side is the fact that the n turns into a k, and on the right-hand side, all the n's turn into k's. Voila. Hence, the k plus 1th term is now our main battle problem. So what we're going to do is we're going to first start off, and this is a little different from last lesson. Last lesson we just had an expression, so we subbed it in. On this one, we're always going to start with the one that's, I guess, just a simple expression, and that's what we're going to work from. We always try and go from high complexity back down to low complexity. If you go the other way, you can do it, it's just trickier. So we start off with the right-hand side, and I'll do it all the way over here. The right-hand side is going to turn into 5k plus 1 in brackets, k plus 1 plus 1. So this is what we're working toward. Next, going back over, let's start with our left-hand side again. Our left-hand side is going to be summation of I equals 1 downstairs, then 5I, and then upstairs it's k plus 1, like so. Now, there's a little thing we can do to this to make it in such a way that it's workable. At the moment, it's totally unworkable. What we're going to do is we're going to unwind the final term in the series and kick it out of the summation. So the final term will be the k plus 1th term. So by that definition, here's my summation. This is the part that I always used to get really confused on. I've wound it back down to the kth term. So k plus 1 became k. And to do that, I excluded the k plus 1th term. Do we see what's happened there? So it counts all the way up to the k plus 1th. I kick out the k plus 1th and wind it back to the kth term. From there, I simply use P of k because my P of k, whoops, where are we? This guy over here, what we have in orange, and orange is the same thing. So we're allowed to just say that what's in orange is simply going to be 5k, k plus 1, all over 2. And then over here we have 5k plus 1. All right, any ideas what we're going to do from here? Mad Dog, your hand almost went up.
Oh, make them both over 2.
Yeah, so whenever you're dealing with a situation like this, one of the first things I always go for is exactly what Mad Dog said. Try and put them on the same denominator. So, put it over 2 and then multiply upstairs by 2. Next step is you've got 2 fractions. You want to combine them into one fraction because over on the right here, they're both as one fraction. So what you can do for that is you can factorize. What's common across both of these? Well, you've got a 5 and you've got a k plus 1. So let's pull out the 5 and the k plus 1. What do we leave behind? We leave behind the k. We leave behind a 2. And it's still all over 2. Now we basically beat the game, but there's a cosmetic change we need to do to this. Over on the right, we've got a 5k plus 1, 5k plus 1. In here, we've got a k plus 1 plus 1. Simply separate the 2 into a 1 plus 1. And what you discover is that oops. Hence, your left-hand side equals the right-hand side. Now to get the final 3 marks, there's 2 more things we have to do. Anyone remember?
Since P1 is true.
Yeah. So we say, therefore P of k plus 1 is true. And then as you excellently stated, Mad Dog, since P1 is true, and P of k plus 1 is true whenever P of k is true, then P of n is true. for all positive integer values of n, or you could just write it like it was in the question there. Any questions? So
That's complicated.
it's the same thing we've already been doing, just in a slightly different context. Where last lesson we're looking for divisibility, and the lesson before that we're just looking for, I can't remember, but we're doing something that looked like this. In this case, we've just got the sigma notation, which we already know how to deal with. The strategy for these ones is that when you get to the inductive case, you wind it back to the peak or peak kth term, and then you just sub the p of k back in. And then it's a matter of we're checking, can you algebra? In this instance, if you know that the final solution's over 2, you try and force both of your, what do we call them? Both of your fractions, sorry, both of your terms to be a fraction with a denominator of 2, and then you start factorizing so you get a single expression. All good? Any questions? Anything unclear or needing more explanation?
Yeah. After you got the 2 denominators to 2.
Yeah, here?
Yeah, line below.
Yeah, okay.
But how you got from the, yeah.
Okay, do you see how there's a 5 and a k plus 1?
Yeah.
I simply extracted them and put them there.
And then what about k plus 2?
K plus 2. Okay, when I take the 5k plus 1 away from this term over here, what do I leave behind? The k.
Yeah.
And then what do I leave behind here?
2.
The 2. So it's a k plus 2. We took away the 5k plus 1.
Yeah, okay.
Do you see it?
Yes, yeah.
Yeah. A lot of factorizing in this topic.
Yeah, right.
A lot of algebraing.
Then you just substitute like k's for
Yeah, I split. Do you see how there's a 2 here?
yeah.
I turned the 2 into a 1 plus 1. 1 plus 1. And then I throw the
How'd you
brackets.
go to the right hand side? Like 5 k plus 1k.
Here.
Yeah.
For every time I see k, I substitute in k plus 1.
Oh, okay, yeah.
Do you see that's why there's parentheses here?
Yeah.
Yeah.
Oh, okay.
You could just write it as k plus 2. So long as you show somewhere that the left-hand side's the same as the right-hand side, then you beat the question.
So what's this series prove?
This is a series because it's summation.
Oh, okay.
Next lesson we look at the product.
And we've done sequences and something else.
Yeah, we've done sequences in our first lesson. Now we're looking at series.
Did we not do something last lesson? Divisibility.
Divisibility.
Ah.
Alright, cool.